Welcome to MRL. This is the continuation of the solutions of the different questions on the pages from 87 to 106 of Ganita Prakash Quadrilaterals chapter CBSE textbook. Now in the previous video we have learned the solutions of examples up to 9 and we are continuing with example number 10 in this. Now this is the second part of the video. Now in the question number 10 we are given quadrilateral here to find the remaining angles of the quadrilateral. That means we are given a quadrilateral PEAR and which is a parallelogram. So quadrilateral PEAR is a parallelogram that is given to us. One angle is 40 degrees is also given. Now in a parallelogram the opposite angles are equal, therefore angle P and angle A are equal, therefore angle A is also equal to 40 degrees. And also if P is 40 then E will be 180 minus 40, that is 140 degrees, because the sum of the adjacent angles is 180. If angle E is 140 then angle R is also 140 degrees. So please remember that. Now coming to the second example here, we are given a parallelogram again PQRS. Angle P is 110. We have to find the other angles here. Now angle P is equal to angle R because opposite angles are equal, therefore angle R is 110. But angle P plus angle Q is 180 because the sum of the adjacent angles is 180. Therefore angle Q is 180 minus 110, that is 70 degrees, and therefore angle S is also equal to 70 degrees. Angle Q is equal to 70 degrees, and that is what is asked from us. Now coming to the next example, we are given UVWX is a rhombus. UVWX is a rhombus, and now here we have to check the angles here, the angle 1 and angle 2. Please understand here, angle 1 and angle 2 are equal because they are alternate interior angle, therefore this is 30, that also will be 30 degrees. But also we know the diagonal of a rhombus bisects the angle, therefore if angle 1 is 30, angle 3 is also 30, that means the total angle V is 60 degrees, and so also angle X is equal to 60 degrees. And if this is 60, we know that angle U plus angle V is 180 degrees because the sum of adjacent angles is 180 degrees, therefore angle U is equal to 120 degrees. But angle U is equal to angle W, therefore angle U is if angle U is 120, angle W is also 120 degrees. So that is what is asked from us. Now again we are given AEIO. AEIO is a rhombus. Angle 1 and 2. Okay, we are given angle 1 as 20 degrees. Angle 1 is equal to angle 2 because they are alternate interior angles, because we know that AE and OI are parallel to each other, and the diagonal bisect each other, therefore angle 3 is also 20, angle 1 plus angle 3, that is 40, therefore angle E is 40 degrees, so also angle O is 40 degrees. But we know that angle A plus angle E is 180. If this is 40, then angle A will be 140 degrees and also angle I will be 140 degrees. Try to remember that. Now coming to the next example, we are given the diagonals of a parallelogram as 7 centimeters and 5 centimeters. The diagonals are given to us. Now the diagonals intersect at an angle of 140 degrees. Please understand, the diagonals are given and the angle at what the angle which is formed between those two diagonals also is given, and we have to construct the parallelogram. So for that, what we will do, first of all, let us draw the diagonal AOC. Let us draw the diagonal AC first, and AC is, as you know, it is 7 centimeters. It is 7 centimeters. Now draw a perpendicular bisector to AC to locate the midpoint O, so that OA and OC are equal, and OA is equal to 3.5 and OC is also equal to 3.5 centimeters. Now construct an angle 140 degrees here. So construct an angle AOD. Angle AOD is 140 degrees. 140 degrees. Now what you do is measure. Please understand, AOD is 140 degrees, and extend this OD on both the sides and extend it to, let us say OD is extended to X there and DO is extended to Y. So we have got XY is another diagonal. Now from O, since we are given 5 centimeters, from O measure 2.5 centimeters and cut an arc, and from O again measure 2.5 centimeters, cut an arc. So that means OD is 2.5, OB is 2.5. We have located the points B and D. Now join AB, join BC, join CD and join DA. We will get a parallelogram of the given diagonals, that is AC is equal to 7 centimeters, BD is equal to 5 centimeters, and also the angle between the diagonals is 140 degrees. So that is what is the parallelogram, and that is how we construct the ABCD with the given information. Now coming to the next example, we are given diagonals of a rhombus. Remember, the diagonals of a rhombus are given here are 4 centimeters and 5 centimeters, and we have to construct a rhombus. So what we will do, we will draw a AC. We will take 5 centimeters. Let us take AC as 5 centimeters here. Let us take AC as 5 centimeters. Draw a perpendicular bisector to AC. Locate the point O. That means O is the midpoint of AC. Therefore, OA is equal to 2.5, and OA is equal to 2.5, and OC is also equal to 2.5 centimeters. Now from the point O, since we are given AD as 4 centimeters, from point O measure 2 centimeters, cut an arc, and from point O measure 2 centimeters, cut an arc again. So we locate the point B and D, then join AD, join AB, join BC, join CD to get the rhombus of the given two diagonals. That is AC is AC is 5 centimeters and BD is 4 centimeters, and that is what is the construction. And if you will find that all the four sides, that is AB, BC, CD and DA, are all equal. We can measure them and they are all equal, and that confirms what is that? It's a rhombus. All sides are equal, the diagonals bisect each other, and the diagonals are perpendicular to each other. So therefore it's 100% a construction of rhombus. Now on page number 103 we have an example here. We are given AC and BD are equal. Okay, AC and BD are equal diagonals. Okay, AC and BD are equal diagonals. AC is perpendicular. Please understand, AC and BD are also perpendicular to each other. Then the ends of the diagonals are joined. We are joining AB, BC, CD and DA. Now the quadrilateral which is formed here is, we have to prove that it is a square. So let us understand this. Now in triangle AOD and triangle COD, we know that OA and OC are equal, because we are given that AC and BD are equal diagonals and they are perpendicular to each other. Therefore OA must be equal to OC, and angle AOD is definitely 90 degrees. AOD is 90 degrees and COD is also 90 degrees. AOD is 90, COD is 90, and OD is common to both. Therefore we have all the sides are equal. That means we have got SAS by congruence criteria. Triangle AOD and triangle COD are congruent if they are congruent but natural. AD and CD are equal. So by taking these two triangles we have proved that AD and CD are equal, and for the same reason we can take these two triangles now, AOD and AOB. Again we can prove that AD is equal to AB. Again we can take the two triangles AOB and COB, or COD and COB, and again show that BC is equal to DC. That means all the four sides are equal. If all the sides are equal in a quadrilateral, the diagonals are equal, the diagonals bisect each other, then 100% it is a square. Therefore ABCD is a square. Try to remember that. ABCD is also a rhombus. ABCD is also a rhombus, but a rhombus becomes a square when the diagonals are equal and they bisect each other. Now coming to the next example, now we are given AC and BD are diagonals. AC and BD are diagonals, but the diagonal BD is AC plus 4. That means it is 4 units more than AC. So we are given AC as a diagonal, and BD is also diagonal, but BD is 4 units greater than AC. Now AC is perpendicular to BD. Please understand this. AC is perpendicular to BD. AC and BD are unequal. AC and BD are unequal. The ends of the diagonals are joined. Now we have to show that the quadrilateral is a rhombus. Now in triangle AOD and triangle COD, we know that OA is equal to OC and OD is equal to OD common. Angle AOD and COD are equal to 90 degrees, because that is what is given to us. We are given that AC and BD are diagonals and AC is perpendicular to BD. Therefore AOD and COD are 90 degrees. OA is equal to OC and OD is common. So by RHS congruency, these two triangles are congruent. That is, triangle AOD and triangle COD are congruent. The corresponding sides are equal. Therefore AD and CD are equal. For the same reason, we also can say that AD is equal to AB and CD is equal to BC. That means all the four sides are equal in this particular quadrilateral. In a quadrilateral, if all the sides are equal, the diagonals bisect each other, and the diagonals are perpendicular to each other, then it is 100% rhombus. Please remember that. But one thing you have to remember, if the diagonals become equal, straight away this rhombus becomes a square. Now coming to the next example, page number 104, question number 12. Now we are given two equilateral triangles here. Triangle ABD and triangle CBD are two equilateral triangles and they are joined at their bases. Now we have to find out the type of quadrilateral formed and also justify it. Now if ABD and CBD are equilateral triangles, then angle AD, AB and BD are equal. So also CB, CD and BD are equal. Now angle A is 60 degrees, angle ADB is 60, and angle ABD is also 60. ADB is 60, ABD is also 60, and similarly angle BCD is 60, angle CDB is 60, and CBD is also 60. Therefore this is angle A 60 degrees, angle C 60 degrees, angle ABC is 120, and ADC is also 120 degrees, and all the sides are equal to 8 centimeters. That means if we have a quadrilateral in which all the sides are equal, opposite angles are equal, the diagonals bisect each other, and therefore it is 100% a rhombus, and there is no doubt about that. Now coming to the page number 104, question number 13, we are given two triangles here which are rather isosceles triangles. Base is 6 centimeters, the sides are 8 centimeters each. We have to join them at the 6 centimeters. When we join them at when we join the bases, we get a quadrilateral. And on this quadrilateral, since all the sides are equal, that is, sides are equal, 8, 8, 8 and 8, so all the sides are equal, and the diagonals bisect each other, and the diagonals are perpendicular to each other, and therefore the quadrilateral what we get is 100% a rhombus when we join two isosceles triangles at their bases. Now coming to the second part of this, and if the same two quadrilaterals, please understand, the same two triangles, if they are joined at 8 centimeters side, if you join them at 8 centimeters, see, we are joining at 8 centimeters here, so we have one triangle here, that is PQS is one isosceles triangle, and QRS is another isosceles triangle. So again we find here the one side PS, another side QR, the opposite sides are equal, that is 8 and 8, and also we have PQ and SR are equal. That means we have the opposite sides are equal in this particular quadrilateral. Now if you take the angle PS and QS being equal sides, opposite angles are equal. Therefore if I take as angle A here, that means angle P and angle SQP is angle A, and so also R is angle A, because again two sides are 8 centimeters. Therefore angle P is equal to angle R. Angle P is equal to angle R, that is equal to angle A. And angle A here and angle A in the second triangle, that is angle PQS and RSQ are equal, because SR and PQ are parallel. Okay, that means angle A is equal to angle A, alternate interior angles, and also angle B and angle B are equal. Therefore A plus B, that is angle PSR and PQ are both equal angles, that is opposite angles are equal. That means looking at the property of this quadrilateral, in this quadrilateral the opposite sides are equal, the opposite sides are parallel. Okay, the opposite sides are parallel because A and A are there, therefore opposite angles are, see, please understand, the interior alternate angles are equal means definitely PQ is parallel to SR, and for the same reason PS is parallel to QR, and therefore opposite sides are parallel, opposite sides are equal, and opposite angles are equal, and therefore it is 100% parallelogram. Now question number 14, page 106, we have been asked to construct a trapezium and confirm its properties. So let us draw a line AB and construct another line, or draw another line DC which is parallel to AB. So we have two lines AB and DC parallel to each other. AD is joined and BC is joined, and therefore we get ABCD as a trapezium. We got a trapezium ABCD because the pair of opposite sides are parallel here. Now measure angle A, it is 68 degrees. Measure angle B, it is 48 degrees. Measure angle D, it is 112 degrees. Measure angle C, it is 132 degrees approximately by my construction. Now when I add 68 and 112, it becomes 180. When I add 132 and 48, it is 180. That means it proves the property that the angles at the ends of the non-parallel sides is 180 degrees in both the cases, and therefore it is very clear that this is trapezium. So therefore when we talk about the properties of trapezium, in a trapezium we have a pair of opposite sides parallel, and we have the sum of the angles at the ends of the non-parallel sides as 180 degrees, and the two other sides are non-parallel. So that proves it is 100% that explains the properties of trapezium. Now question number 15, page 106, we have to construct an isosceles trapezium UVWX. We have to construct an isosceles trapezium UVWX with UV parallel to XW, and also measure the angles and confirm the properties of the isosceles trapezium. Let us understand this. So let us draw a line UV and draw a line parallel XW to it, and then get ux equal to pw. That means construct line segment ux and vw such that they are equal. So that means in this particular quadrilateral we have uv parallel to xw and ux is equal to vw. 100% it is an isosceles trapezium. Now if you measure u, it is 62 degrees, measure v, it is 62 degrees. Now measure w, it is 118 degrees, measure x, it is also 118 degrees. Okay, so that is very clear that this is an isosceles trapezium. That is how we construct and also confirm the properties. Now in the same example here, we have been asked page number 16, question number 16, page 106, we have to find the congruent triangles in the isosceles trapezium UVWX and to show that angle U and angle V are equal logically. Now let us do one thing. What we will do here, let us draw xy perpendicular to UV and also draw WZ perpendicular to UV. Now we get two triangles here, that is XUY and XUY and WVZ. Now in these two triangles we know that ux and vw are equal, therefore one side that is equal, and also we know that angle xy and wz are equal because they are perpendicular distance of two parallel sides, and also we have this angle here, that is xyu and wzv as 90 degrees because we have drawn xy perpendicular, wz perpendicular to uv. So by RHS congruency these two triangles are congruent. If two triangles are congruent, their corresponding angles are equal, therefore angle u is equal to angle v, and that is what is asked from us. If angle u is equal to angle v but natural, angle x will be equal to angle w. That proves the base angles of isosceles trapezium are equal, and that is what is the proof of the properties of isosceles trapezium, and also the proof of that angle u is equal to angle v. So these were a few examples which we have discussed. Still it is not over. We will be continuing the solving examples of this quadrilaterals chapter in the next video from question number 17 onwards. So learn these examples. Purposely I have made them shorter videos so that you can concentrate and learn and then proceed further with the next video. So go through them, practice them, note down them in a book so that you can keep them as a reference for your future study. Okay, thank you.